Good day, I'm Domingo Haniluar and this is Basic Electrical Engineering. Problem number 1. The field current of a 210 kilowatts, 440 volts DC shunt generator is 8 ampere when running full load at rated terminal voltage. If the combined armature and brush resistance is 0.04 ohm, solve for the electrical efficiency of the generator. Note, electrical efficiency is the percent ratio of power output over its input power. Given, field current is 210 kilowatts and it is equivalent to 210,000 watts. Load voltage is 440 volts. Shunt generator is 8 ampere. Brush resistance is 0.04 ohm, and we are going to look for electrical efficiency. And these are the solutions. Load current is field current divided by load voltage. So 210,000 watts divided by 440 volts is equal to 477.27 ampere. Armative current is load current plus shunt generator, 477.27 ampere plus 8 ampere is 485.27 ampere. Efficiency of DC shunt generator. Power input. If we manipulate it, N equals to field current divided by field current plus armative current squared times brush resistance plus shunt generator times load voltage times 100%. So 210,000 watts divided by 210,000 watts plus 485.27 ampere squared times 0.04 ohm plus 8 ampere times 440 volts times 100%. The answer is 94.20%. Problem number 2. The equivalent armature resistance of a series motor is 0.3 ohm. When connected across a 440 volts mains, the armature takes 25 ampere and its speed is 1240 rpm. Determine its speed when the armature takes 60 ampere from the same mains with a field increase by 10%. Given, series motor, load voltage is 440 volts, armature equivalent resistance is 0.3 ohms, current taken is 25 amperes, speed is 1240 rpm. Series motor, load voltage is 440 volts, armature equivalent resistance is 0.3 volts, current taken is 60 amperes, and we are going to find the speed. And these are the solutions. Armature current IM is equals to IA, so IA is 25 amperes. EB1. EB1 is equals to VS minus IA times RA plus RSE. EB1 equals 440 volts minus 25 amperes times 0.3 ohms. EB1 is equals to 432.5 volts. EB1 increased by 10%. EB1 equals to EB1 plus EB1 times 10%. EB1 equals 432.5 volts plus 432.5 volts times 10%. EB1 is equal to 475.75 volts. EB2 is equals to VS minus IA times RA plus RSE. EB2 equals 440 volts minus 60 amperes times 0.3 ohms. EB2 is equals to 422 volts. Speed is N2 divided by N1 equals EB2 divided by EB1. If we manipulate it, N2 equals EB2 times N1 divided by EB1. N2 equals 422 volts times 1240 RPM divided by 475.75 volts, the answer is 1099.91 RPM. Thank you for listening and God bless everyone.